For me in my classroom, one of the most important things I can do is to make very few statements and instead to see if I can get students to make realizations about new material based on a series of questions.
Oh, and she wants me to put parentheses. Is it appropriate for me to put parentheses? Is it okay? Output is equal to the input times 4. Is that what that means right there? Multiplication. So where's the point? Is it down in the bottom or in the middle? What's different about these two? Beautiful. All right. Talk to me now. What's happening? What do you see?
Even when I'm working with a student individually, my work with them is often a constant series of questions.
Tell me about this one right here. Oh, multiplying the groups? That's what that means? Can you point to the function? Where is it?
Over the top.
There it is.
Times 50
Okay.
plus 1.
Do you agree with that?
We really try to build a culture where the teachers, we're asking questions constantly, trying to help students come to their own mathematical realizations.
How much money is this right here?
I'll ask, they'll give me a response, but I'll always follow it with, how did you get that? Or, convince me that that's correct, so that when I walk away, the students have a model and it happens even when I move away.
Tell me about this one.
This one, -1.
What's that -1? What's that like? Does that mean my wallet's empty over there?
You don't have nothing in your wallet.
Well, what
but
there?
you owe $1.
Okay.
All right, and then plus another $5 that you would debt.
Okay.
So, or you got a $6 debt.
Good. Very good.
Sometimes the best thing I can do when I'm working with a couple of students is to walk away and say, keep working on that.
All right. How about this one? S. How do you say this? S.
S
Fine.
of 50.
Fine S of 50. What?
Many times I think teachers can do too much for students, and that sometimes the best thing we can do for them is to make sure they're on the right track, give them a little bit of guidance through questions to keep them on the right track, but then to get out of the way and let them find their own way to the solution.
Okay. And what should we do with 50?
50 times -5.
Which is?
100. -100.
You guys think about that one.
Yeah, 50 times -5.
Many times if I ask a question and I sense instantly that there's more than one answer, I'll just start to put them up on the board.
Okay. The input times 2?
First of all, to keep track, but to also have them realize which ones are the same, and to ultimately figure out which are the ones that followed correct reasoning.
Hold on. Before we go to a different one, I want to make sure we think through what she said.
Sometimes that exploration can really clarify exactly what you want students to know, so that those wrong answers are really some of the best opportunities for learning.
If it turns out x is 5, what's 5 times 2? 10. Is that the same as x times x? No. Why? What's? Oh, it'll be 25. So be careful.
The Greeks thought that every rock would hit the bottom first, but they were wrong.
They were wrong?
They were wrong.
What do you think?
That's right.
This is a nice blackberry. So if I take this, and I take you, and I drop them out the window,
Gonna hit the floor at the same time.
You believe that?
So I'll often, when a student answers a question from me, I will redirect their response to others. Do you agree with that? Do you agree with that? Convince me that his or her answer was correct.
It don't matter. Gravity's
You think they'll hit the same time? The blackberry and him?
I disagree.
And I like questions where disagreements are going to be created. So we were working with a problem involving Galileo's understanding of how fast objects will fall.
Okay, how many people believe what the Greeks claim, that the heavier the object, the faster it will fall?
So when I repose this to the class as a whole, I realized we had quite an intense disagreement about it. And that's great. That sort of creates the curiosity, creates a basis from which students are going to want to try and explore this a little bit deeper.
This is long, so okay, maybe that.
6 times all the chicken.
Same time.
All right, we're going to have to do an experiment. I'm going to figure it out over the next week or two. So we'll do something here. And it will involve Nigel's BlackBerry, I assure you that. So
One technique we use often is to have students look at a statement.
does this equal that?
And decide on whether or not it's true or false, or in some cases if it's always true, sometimes true, or never true.
Okay, you know who you're talking to? So start talking to them.
How can it go on x squared if the first
He
one?
asked if that's true or not.
I think it's not true.
One square is always one, so it's equal. So it's sometimes. But if you put like a different, if you put like
Always true.
right, so it's sometimes true. It depends on the number that's in it. That's what we said.
What are some values of x that you tried, so that instead of saying here's a property that I want you to write down in your notes and to apply, but to have them look at the relationship and decide for themselves what's going on here? Does this work?
How about here?
Yes.
Want to see, does it work here? X equals x squared in this case?
Yes.
Okay.
When teachers make statements about new material to students, students are very passive. They will write down what the teacher has said, and they're not really doing any math. But in my classroom and in classrooms in our college transition classes, it's much more active for the students. We're asking questions constantly, trying to help students come to their own mathematical realizations, which deepens their conceptual understanding.